Welcome to the House of Maths and my next vector question. Here it is, 10th one, and again it's going to be a hard one. So here's our shape and we're given some information about it. Up here we're told that OA is A, so that's O to A. I'm going to put that vector in and call it A. We're told that AN is 2OA, so A up to N is twice this here, so that's just going to be 2A. So I've put that one in as well. Then we're told that OB is B, so that's O to B is vector B. And we're also told straight underneath it that M is a midpoint, so this is halfway. So as it's halfway, I'm going to do this in 2 bits. I'm going to call this bit here half B, and that bit there will also be half B. And we are told that AP is KAB. So AP, so this vector here from A to P is a proportion of that vector AB. So K is that proportion, or that fraction of that whole vector. That's what that tells us. And then we're told, given that MPN is a straight line, find the value of K. So MPN is a straight line. So I'm just going to put that in as a straight line. So there it is, and we know it's a straight line. So it looks like from the question that we're interested predominantly in this bit here, A to P. So we're probably going to have to find that section or that vector in 2 different ways, and that will then help us to enable us to find out what this K part is. So we're going to end up finding this in 2 different ways and comparing coefficients. That's the way we're going to do this. So let's see how we can do that. So in order to get AP, we're first going to need to get AB. And we can do that using the vectors we've got. We can go down here and across here. So AB is going to be that there. So notice that we're going in the opposite direction. So it's going to be negative A, and all the way across here is B. Okay, so that is the vector AB, and AP is a fraction of that. So some fraction K of, like so. All I'm going to do now is just multiply that out to keep it simple. Okay, so we found AP in one way. We now need to find it in another way. So looking at the diagram, the easiest way to do this looks like to go from A up to N and back down to P here. That will get us that vector. Well, we know that bit there is 2A. We haven't got this bit here. So we're going to have to find that. So we're going to need MN first. So over here, I'm going to write MN. So how can we get that? Well, we can go down to here and up to here. So notice that we're going against the direction of the arrow. So it's going to be negative this vector. And then we're going to go from O all the way to N. Well, we're following the vectors. So we've got A, 1A here and 2A here. So that's 3A. So that's the vector MN. Okay, but we're only interested in PN. So that's going to be some fraction of this vector. So let's call that fraction n. Okay, so that's Pn. And all I'm going to do now is just multiply out the brackets. So Pn like so. So that's Pn. Now we're interested in AP. Remember, we've already worked out AP as a fraction of this vector. So now we want it in a different way. So we're going to go up here and down here. We've got this bit now. Here it is. And we know this bit is 2a. So we're going to go 2a. And then we're going to come back down here. Well, we've worked out that vector in that direction. Here it is. So we're going to get a negative of that. So a negative of that is just going to flip those signs. So we're going to get plus half NB minus 3NA, like so. So that is our AP. Now I'm going to factorise the A's. So we've got 2 lots of A in there. So I'm going to pull A out as a common factor, and I'm going to get 2 minus 3n plus. So that is AP. Now what I'm going to do is write this underneath that one. So that's A 2 minus 3n plus half ND. So here we are, we've got AP as a fraction of this vector, and we've got AP as this. So we found it in 2 different ways. Now we should be able to compare coefficients. So this coefficient of A should equal this coefficient of A. So we can say minus K should equal like so, and we can say the same things with the coefficient of B. So this coefficient here, K, should equal this coefficient here, half n. So these are our 2 simultaneous equations, here and here, where we've compared coefficients. So what we can do here is we can work out one and substitute into the other. So this one, we've already got K equals something here. So we can just substitute this into there. So we're going to get minus half n equals 2 minus 3n. And then we can solve this because we've only got one unknown here. So I'm going to add 3n to both sides. So I'm going to get 2.5n equals 2. Then I'm going to divide both sides by 2.5. And now I'm just going to multiply the top by 2 and the bottom by 2. Okay, so we've got n equals 4 over 5. And that's useful. We are trying to find, remember, we're trying to find the value of k. We've not got there yet, but we've got n. So we can then take this and substitute it into here, and then we can find the value of k. So let's do that. So k equals a half, and then we're going to put the n in. So all I've done there is simplified. 1 times 4 is 4, 2 times 5 is 10, divided by 2, so we get 2/5. So k equals 2/5. Again, so I've done a few of these fairly tricky vector questions where the same kind of approach is needed in each case, where you're interested in a particular part of a vector which you've not got the fraction of, in this case k that we're interested in here. So as with the others, you've got to try and find this section in two different ways. Quite often you're going to end up with two unknown fractions, but you will end up with a situation like this where you get simultaneous equations and you can compare, well, from comparing coefficients, and then you can substitute one into the other and solve. Okay, so it's quite a neat approach. I hope you enjoyed that. If you did, please remember to hit the like button and consider subscribing. Thanks for watching.